Today we're going to talk about polar coordinates. So you probably talked about it a little bit in your last trig class or algebra class. So today we're going to kind of refresh your memory. The coordinates you're used to seeing are called rectangular coordinates. So that's going to be your typical XY coordinate. And it's called rectangular because we understand everything in the grid essentially as rectangles. So for example, the coordinate 2, 3, you go over 2 to the right and then 3 up, or you go 3 up or 2 to the right. Notice how everything is just some form of a rectangle. So now, today we're going to be talking about polar. So polar coordinate is just another type of coordinate. And the way it works is you're using the same plane, except now we're thinking about r and theta rather than x and y. Now what r is going to be is this: the distance from the origin, and theta is simply your rotation. So just like our trigonometry work with triangles, positive rotation is going to be counterclockwise or up first. Negative rotation is going to be clockwise or down first. So if I want to try this first example, let's do A right here, 2, 135. What we're going to do is imagine you're standing right here at the origin. Really focus on this 135, and that would be right here, 3 pi over 4, and then you walk 2 units out. So each ring is a unit, so just go 1, 2, that's your second ring, and that's going to be your A. Now if you imagine it kind of pictorially, you can imagine this line, it just rotates to 3 pi over 4, and then it shortens to 2, right about there. I'll put the line back right here. So for the next one, 3 pi over 2 negative 3, I like to teach focus on the angle first. So look at 3 pi over 2, that's right here. And notice how it's negative 3. So rather than walking 3 units towards 3 pi over 2, you just walk 3 units backwards. So go 1, 2, 3, there's B. So again, if you imagine this as if you're a visual learner, imagine you're looking at 3 pi over 2, but then you have to go backwards 3 units. And then land at B right there. Okay, I'll put this back. So last one, negative pi over 4. So focus on that. So we're going to rotate down to here, 7 pi over 4. And then notice how it says negative 1, so it means we're going to go backwards. So we're going to go back 1 unit. That's right here. We'll call that C. And again, if I want to use my picture or my line here, we're looking at 7 pi over 4, and then just go backwards until you're at about 1. Right about there. Okay, put that back. So that's number 1. Let's go to example 2. So in example 2, let's highlight some important information. It's saying, here's a point, 2 pi over 3, it's plotted. I took the figure out to save space, and then find another representation. So essentially, let's kind of sketch it now. So if you're doing this on paper, the easiest thing to do is just imagine where pi over 3 would be. That's like up here. And then basically go to it and put like 2 tick marks like that. So there's our picture, our plot of 2 comma pi over 3. Now it says r is positive for A, so what we're going to do is we're going to rewrite the point. So if r is positive, that means keep r at 2. But then it says the theta must be between 2 pi and 4 pi. So again, if you imagine this line of 2, I'll put that as my red line, that means like you rotate once and rotate again to land at that same line. Which means all we have to do is simply take pi over 3 and add 2 pi to it. We do that and we get 7 pi over 3. So for B, it says r is negative now. So r is negative 2, and theta is a regular rotation. So if you think about that, that would mean we want to face right here. Because if we face there and we rotate to there, we go backwards 2 units, and that will line up. So think about what angle that would be. That would be 4 pi over 3, and that's it. -2, 4 pi over 3. Last one, r is positive, so let's make r positive 2. But theta is negative. Okay, so that would mean that we just have to take this red line, figure out that negative rotation that way. So let's think about that. That negative rotation would be -5 pi over 3. And there it is. Okay, let's go to the next part. Now it says find the rectangular coordinates of the points with the following polar coordinate. Okay, so that's going to mean we need to convert from polar to rectangular. Okay, now there are a couple ways to do this. I always recommend to draw it so you can kind of think about what it actually looks like. So if you imagine 2, 3 pi over 2, 3 pi over 2 is right here, and then just go follow down 2, and there it is. There's your answer. 0, -2. Now there is another way. What some people like to do is to use some trigonometry, because there's some really easy formulas to apply. Because if you think about what we're doing here, imagine that this point right here is the polar coordinate. We can kind of link everything together using trigonometry, because think of this as x, that's y, that's r, that's theta. We can make a pretty cool relationship here. Let me draw a line for you. We can say that cosine theta is x over r, and sine theta is y over r, which would mean x is r cosine theta, and y is r sine theta. So again, I'm going to write that right here for you. X equals r cosine theta, y equals r sine theta. Some people just use these formulas for everything because they're pretty useful and pretty simple. So for letter A, I could just write x equals 2 cosine 3 pi over 2, and y equals 2 sine 3 pi over 2, and just do our unit circle values. X should equal 2 times 0, which is 0. Y should equal 2 times -1, which is -2. The coordinate is 0, -2. So notice how that's pretty easy. So for B, I'm going to try that again for you. So x should equal -8 cosine pi over 3. Y should equal -8 sine pi over 3. So x should equal -8 times 1/2, which is -4. Y should equal -8 times √3 over 2, which is -4 √3. The coordinate is -4, -4 √3. So notice how it's pretty easy now. Now this one's cool because it says 2, 2, but you have to realize this is a polar coordinate. So that 2 is actually in radians there. So really that's approximately like 120 degrees. So we obviously can't do this by hand. We need a calculator. So all you do is you grab your calculator, type in 2 cosine 2, and make sure you're in radians, and you get -0.83. You type in y equals 2 sine 2, and you get 1.82. And again, it's important that your calculator here is in radians. So your coordinate is -0.83, 1.82. And notice how this coordinate would be in quadrant 2, which makes sense because 2, 2 would be like 2, 120. And if 120 is right here, you'd be like somewhere over here. Okay, here's the last part. So now we're going to go the other way. It says find polar coordinates for these rectangular coordinates. So if you look back at this thing right here, I'm going to do a couple more generalizations. So we found these two facts earlier, number 1, number 2. Let's do another couple observations here. We can actually see that x squared plus y squared equals r squared. That's by the Pythagorean theorem. And the fourth fact is, look at that, I can write tangent should equal y over x. Now that might not seem that important, but you're going to see why those extra facts are going to be very helpful. Okay, so there's fact number 3, fact number 4. For these, I recommend drawing it because it's going to make your work a little bit easier. So this is in quadrant 2. Let's draw a triangle here. -1 root 3. Here's our theta. We want to figure out the hypotenuse for polar, right? We want to figure out this part. So hopefully you can do the Pythagorean theorem in your head. You can see that's 2. So notice if we're looking for r comma theta, we already have 2. And again, that's just from using x squared plus y squared equals r squared. The problem is that theta. So to find that, we're going to write tan theta is equal to y over x, which is root 3 over -1. And now look, it's just like our last chapter. Tan theta equals -root 3, so theta must be 2 pi over 3 or 5 pi over 3. However, the picture's in quadrant 2, which means it couldn't be 5 pi over 3. There's our angle. So I'm going to write 2 comma 2 pi over 3. And there it is. Okay, for B, same thing. Let's draw it out. So here's -2, -2. That's quadrant 3. Here's our angle theta. Pythagorean theorem, that's 2 root 2. So far we have 2 root 2 comma something. We're going to do tan theta equals -2 over -2. So tan theta is equal to 1. So theta must be pi over 4 or 5 pi over 4. And again, this is why you have your picture. Your picture is in quadrant 3. So deny pi over 4, that's your angle, 5 pi over 4. Circle that one. Okay, last example. We have -1, -5. So again, draw. This is again in quadrant 3. Okay, so let's just put that down. -1, -5. So this one, we're not going to be able to do by hand, as you probably noticed. The hypotenuse is root 26. So already I'm going to write that for you, root 26. We don't know this angle theta. I'm going to write tan theta is equal to -5 over -1. So tan theta is equal to 5. So we definitely can't do that in our head. So this is why we're going to need a calculator for this one. To solve for theta, simply just do arctan or tan inverse of both sides. So theta is going to be tan inverse of 5. Now your calculator is going to give you something interesting. It's going to give you 78.7 degrees. Now it's up to you to realize that is not the answer, because if you look at our picture here, our picture is in quadrant 3. The angle theta rotates all the way down. So the 78.7 you just found right here is actually just that little piece right here. Let me highlight that a little better. Right here. So to get the full rotation, what you're going to have to do is simply add 180 to this. So again, you have a calculator, so you could do it by hand, but if you have a calculator, just type it in. 180 plus 78.7, you get 258.7 degrees. So for the calculator ones, you got to be a little creative, because you have to kind of think about how to get the rotation you want.